John, thanks for being here again, and please help us to better understand OpenShift.
I can do it, Luke, and appreciate you guys having us again. Again, I'm John Walter. I work on the training and certification team here at Red Hat. My role is really focused around enablement, making sure that our customers and that our partners and their customers understand not just the technologies, but what kind of training that we can provide here at Red Hat as well. Quick look at the agenda. We're really going to start at the smallest unit of compute. When we talk about OpenShift, we really need to kind of set the stage at the container level, right? Why are organizations even moving towards containers? From there, we'll move into what is Kubernetes, right? Kubernetes is really kind of the, at the heart of OpenShift and a lot of the other Kubernetes services out there. What is Kubernetes? What is the purpose of that tool? What is container orchestration? And then from there, we'll move into, what is OpenShift? And that's really kind of the enterprise Kubernetes platform. Towards the end, we'll wrap up with a little overview of some of the training offerings that we have available to you through Global Knowledge. And Luke and his team definitely be able to assist on that side as well. And again, if there are any questions, I'll try to answer them if I can in the moment. Otherwise, we will have some time for Q&A towards the end. But packed agenda, let's jump right into it. So, first and foremost, what is a container? And really you have to sort of take a step back, and we have to really set the stage for where really the entire industry is moving. If you've heard the term digital transformation once, you've probably heard it a million times. If you're like me, you kind of roll your eyes when you hear it, but digital transformation really does represent a lot of what our customers and really a lot of organizations out there are doing right now. And really, when we talk about digital transformation, we're talking about how to become a great or a more efficient software development company, right? Or maybe just software company, right? And doing that takes a lot of different steps, right? Adopting something like OpenShift as a platform is part of those steps. But really, when you look here on the left side, you're seeing really how things have been done traditionally, right? Teams are siloed, much more of a waterfall method. We're deploying into data centers as opposed to the cloud. We are still working largely on physical servers, virtual machines. We haven't yet moved those workloads to a public or private cloud yet. From an application perspective, we're still building these monolithic applications. And we need to start to move towards, CICD, continuous integration, continuous deployment, away from waterfall. So, how do we adopt DevOps? That's a big part of this. We are going to start moving from those data centers towards a cloud. And, that's not to say that there's not a place for data centers anymore. There's not a place for virtual machines anymore. But, where Red Hat is, and if you aren't familiar, IBM acquired us a couple of years ago. And really the big part of that is because of Red Hat's place in this open hybrid cloud, right? We want you to have the experience where you can deploy your applications on a platform that could be running anywhere on AWS. Maybe it's managed by AWS, or maybe it's something you're managing yourself. Maybe it's something you have deployed in a data center as well. The experience for you as an administrator, as an operations person, as a developer should be the same no matter where it's actually deployed, whether it be on a self-hosted private cloud, something that's managed by one of the public clouds, or just running on bare metal. So we really kind of talk about the goals of these steps, what we're really focusing on in terms of three quote unquote business outcomes. So that's speed, agility, and control. When we talk about speed, we're really talking about how quickly we can deploy. When we talk about agility, we're talking about how agile we can be, how quickly we can make new updates or new commits to specific processes or applications. How quickly can these changes be done, and how can they be more simplified as far as the process, more streamlined, so that we have more freedom to kind of experiment within these different roles. Especially when you're a developer, you're usually much more bleeding edge. When you're kind of on the IT ops or administration side, you want a little more tried and trusted. So, how do we enable both? And then control, right? How do we mitigate any kind of risks and security, any kind of issues with bugs? How do we approach them more quickly when they do come up? So that's really all of what this kind of push towards digital transformation is. And if you look at it from a more of a kind of technical perspective, really it's how do we move away from these kind of traditional integration towards more of an agile integration, right? We want to move away from like enterprise service buses. We need our applications and the way that we're designing them to be more agile. And with that, we need the technology that we're using to be more agile as well, to be more scalable, to exist across multiple clouds, and to be able to be iterated more quickly and more efficiently. And so you're going to start to see that the applications that we're building, the way that they're integrated with each other becomes a lot more modular, because that really enables things like continuous integration, continuous delivery. So what are containers? It really does depend on who you ask. When you talk to an infrastructure person, their approach to containers is much the same kind of approach that they would have to, say, a Linux virtual machine, or to just a Linux system on its own, right? It's applications where the processes are on a shared kernel. Think of a container almost like its own self-contained hypervisor. It's much lighter, much less of an uplift than a virtual machine is typically going to have. And it's portable across multiple environments, right? There's a standard for containers where they're now standardized to run really on any kind of environment, right? So, a container that we would provide would run on OpenShift, the same that it would run on bare metal, the same that it's going to run on OpenShift deployed on AWS, or even something like Azure Red Hat OpenShift, which is a Microsoft Azure managed OpenShift offering. So, from an infrastructure perspective, when we look at just the container, not looking at the platform that it's running on, a lot of the same kind of technology, and we'll touch on that in the next couple of slides, are shared with containers themselves. These are typically Linux containers, and you can go in them and do a lot of the same kind of things that you would as a Linux administrator. From an application developer standpoint, it becomes really, really exciting as well. This is an opportunity for application developers to actually build their applications with all the dependencies essentially wrapped, and think of it almost like a zip file, where now you no longer have to deliver this list of requirements for your actual application. You can know that this containerized version of my application is going to run the same here in my test or dev environment as it's going to when I move it to one of those different environments. And that's really where we can start to have more of a clear delineation and responsibilities. Beyond that, they become really, really easy to access, to spin up, and to share. I touched on this a second ago, and we'll dive a little bit deeper later on, but containers are standardized. There is a standardized format for these container images. And so not only does that make them easy to move across multiple environments, it also makes it really, really easy to share outside of, say, your specific environment, your specific team, and allows you to really iterate on it and have facilities in place like continuous integration, continuous delivery, or GitOps or Subversion, or whatever it is, to do things like version control really, really efficiently. So we're going to kind of pivot and sort of set the stage as to why organizations are starting to move towards containers. And really, a lot of them are moving away from traditional virtual machine infrastructure towards containerized workloads. And a big thing here is, typically organizations have co-located multiple applications on a single virtual machine, and that's due to operational overhead, resource costs. Maintaining virtual machines can be quite expensive, right? You're spinning up an entire environment and potentially only able to run a limited amount of applications, because what's happening within that environment, well, at the kernel level, at the OS level, there are dependencies that application requires. And if you have multiple versions of an application that require multiple versions of a specific runtime, or whatever dependency it is, you now have to spin up another virtual machine to run that other version of this application. Or if you just have a separate application altogether with completely different requirements and dependencies, you're having to run multiple virtual machines in order to manage that. That can become really, really costly, right? And while virtual machines are isolated from each other via the hypervisor, the applications that are running on the virtual machines typically don't have that much isolation, and they can potentially negatively impact each other, right? Whether it be writing to files that maybe another application is going to be accessing, or changing configurations, or just altering the behavior, right? There's things that you have to account for that maybe you can't expect, because that isolation isn't really built in at the hypervisor level, because as far as the application is concerned, it's running right next to that other one. On the flip side, Linux containers, they share a container host and a kernel, but at the same time, they use a lot of the different kernel technologies that you Linux folks out there are going to understand, things like control groups, SE Linux, kernel namespaces, and all of this really provides isolation so that one container can't access or impact the other containers that are running on the same host, and also can't impact the host itself, right? So there is really true isolation with those containers, and that does present some complexity, right? How do I get these two applications? Maybe I have a web server and I have a database, and I need that database to serve as the backend for my web server. Right now, I need to have these containers actually be able to communicate with each other. Stay tuned. That's really what Kubernetes and OpenShift do. But in a way, Linux containers are a virtualization technology, right? Virtual machines are for virtualizing the hardware, while containers are more for virtualizing the actual processes of the application, no matter where they're being run. And so you can kind of see this broken down a little more granularly than I had before, but you see here in the two images or graphs here, or diagrams. On the left side, you've got the VM, everything in purple, that's the virtual machine, right? And so inside of that, you've got the application, you have your operating system, and you have the dependencies for the OS. On the right side, you're seeing the container really wraps just the application in those OS dependencies with the container itself, right? And so you can have essentially the dependencies for the application be completely different than what the actual OS dependencies on the host actually provide. And so it really does provide a lot of flexibility, and it reduces a lot of the amount of resources that are required for the container itself, and you can. It's significantly more lightweight than virtual machines. Being able to scale is another big part of this, right? Virtual machines, they have a big advantage because they provide, the hypervisor level isolation for an application, but that comes at the cost of running a complete operating system, right? For each application, and that's going to consume memory, that's going to consume CPU, and when you are provisioning those virtual machines, the compute, the memory capacity, all that's predefined, right? You don't have a lot of room for elasticity or for bursting when an application requires more memory or more compute power. You really just have to spin up another virtual machine, another instance, and maybe that's automated, but that again is really resource intensive. Containers provide a much more flexible model when it comes to those different resources. They allow for resource bursting modes so that applications can consume more resources when it's actually required within a kind of predefined boundary. So really, really efficient as far as, especially when you're scaling an application up or down based on traffic, and having a lot of logic built into the platform for that as well. But we'll get to that in just a second. Now, I touched on this a little bit earlier on, but really this is very much tied to DevOps adoption. I would say that DevOps adoption within the last 5 years or so is really, really skyrocketed, and it really coincides with the proliferation of containers within our industry. It's not a coincidence at all, right? The containers have played a very, very important role in enabling organizations to start to implement DevOps practices without having a lot of the obstacles that virtual machines faced, from an infrastructure perspective, from a development perspective. And when you look at virtual machines as kind of the unit of compute, applications are developed by dev teams. The result is then delivered as some kind of arbitrary package. It probably depends on the team, depends on the application. And that's delivered to the IT operations team that are then responsible for actually building and deploying and managing the virtual machine that's going to be sitting on, and the operating system and the libraries and the dependencies, and then managing the application itself, right? And so we're now kind of handing over control to a team to manage an application that not only do they probably not understand the nuance to, but had no hand in actually developing. And so they're not familiar with it. They have to rely on instructions from the development teams if provided. Sometimes that can be a lot of instruction that's very helpful, and sometimes not so much. When you look at containers, it creates much more of a boundary between the different layers of the tech stack. And so it means that you're really clearly kind of defining what the IT ops teams are kind of responsible for, I should say, versus what dev teams are responsible for, right? The devs are going to be deeply familiar with the application they built. They'll know everything about the dependencies, about the configurations. With containers, they own all of that stuff, right? They don't have to rely on an application team to provide the correct configuration, to provide the correct dependencies. They've packaged that with the application themselves. And so they're able to hand over essentially an image, a golden image of their application that has all the dependencies it needs to run. And the ops teams can really just worry about the infrastructure. They can deploy it. They can bring in the development teams whenever things need to be troubleshooted. From an application perspective, they can really worry about troubleshooting on the platform side. And there's a really set standard procedure without needing to kind of adapt it for every single application. So, to summarize, using containers, these teams, they can work at different speeds. They can upgrade and downgrade the servers and the applications independently of each other. They can easily move applications between the different environments very, very quickly, just to lift and shift. And it allows those two different teams to really work seamlessly during the application delivery cycle, and it lays the groundwork for really enabling DevOps across the entire organization. So we'll skip ahead real quick. What you're seeing here is really just how portable these containers are, because the application itself is within this container that comes in a standardized format. You can run it anywhere, right? You just need an OS host underneath it to sit on. And that's outside of something like a full-on platform, right? You can run, let's say, a Docker container from a Mac if you wanted to. You can install Docker on your on a Windows machine, obviously on a Linux box, and you can run those containers right there on top of it. And you should see the same experience no matter what the underlying infrastructure is, because everything is being taken care of at that container level. And that standard format, I don't think I've actually mentioned it, but it's called OCI, Open Container Initiative. It's essentially a standardized image format. And they are dependent on Linux. So it's I would say something like 70 or 80% of containers out there are Linux containers. And so, from an infrastructure perspective, your teams who may be, if you have a Linux team in place, they're going to really be able to hit the ground running working with containers as well. And there you go. There's the stat right there. Now, this is as of a few years ago, this stat is actually increased significantly. So I'll need to update this slide. But essentially, you can see what this looks like from a Linux perspective, right? Here in kind of this gray outline, you have really any kind of infrastructure. On top of that, you have the actual Linux container host. That might be RHEL, that might be RHEL Core OS, it might be some other flavor of Linux. And then on top of that, you have the containers running themselves. Now, there's a lot of complexity that comes with this, right? As my I guess workloads grow, what I'm going to be responsible for is going to grow. Running containers natively on the OS is totally fine, but it doesn't scale. It's not something that you would want to do at the enterprise level. It's really, I would say, I give this example all the time. My dad is self-employed. He's a real estate appraiser. He wanted to build a website, and he wanted to have the ability to do scheduling for appointments, and he wanted to be able to take payments. And so I really, really easily, just using a couple kind of provided stock container images, I spun up an Apache web server. I used like a total template to just drop in the actual HTML. It's been a while since I designed a website. Spun up a separate database for the actual scheduling piece. And then there was a service out there that did payments that was available within our container repository or registry. And so I had 3 separate containers that were running on a Linux box that I have in my guest bedroom. And that's my dad's website. It's 3 different services that are running. I'm running them directly on RHEL. No need for a platform to manage these things, because my dad's, as much as I want his business to explode, he's not getting 1 million hits a day. So no need to really scale beyond that. But obviously, when we talk about the enterprise, they may be getting 1 million hits a day, or at least maybe they're getting 1,000 hits a day. Either way, we need to be able to scale. We need to have processes in place that can do so. And running containers on their own isn't quite enough. And so just to summarize real quickly, containers in a nutshell, they're really transforming the way we think about application architecture, the speed at which teams can deliver on these different business requirements. And they promise things like application portability across all kinds of different environments, enabling for the hybrid cloud. They allow developers to really just focus on building their apps instead of having to worry about the underlying infrastructure, any kind of execution details. And while containers remove complexity by really minimalizing, managing container deployments present a lot of new challenges for these ops teams. Containers are deployed for a lot shorter periods of time than your virtual machine is going to be, right? It's typically going to be much more utilized and probably they will be accessed more and probably utilize more resources underlying. And related technologies with containers, they have to manage a lot more objects that have a lot more turnover, right? It introduces the need to have really automated and policy-driven management. And so that's where something like Kubernetes comes into play, right? Kubernetes has this set of really complex features that can help orchestrate and manage containers across your test and dev and production environments. And it's really emerged as the standard for container orchestration and container management, really becoming a very critical platform. So let's transition now into the what is Kubernetes piece. And I always get giddy when I see this slide because it means the next slide is my favorite slide, this somehow I manage slide. I gave the example just a second ago in my dad's business, 3 containers that's so easy for me to manage. I pretty much check on it on maybe a monthly basis and make sure that the server is still up and running, perform any updates that I need to. Really easy to do that at a small scale. But containers, they're popular because they allow an application, to run wherever you want. And think of it really, again, as a kind of a zip file, right? They're a way to bundle the code, the configuration, the dependencies in an application. And ideally, that application is going to produce the same output no matter where it's deployed, because it makes it a really kind of easy ideal to reach. Containerized apps are going to start, stop, make requests. They'll log the same way across all these different environments. But how do we scale, right? How do we update the applications? All of these kind of things have to be considered. And as we start to move away from these giant monolithic applications, move more towards things like microservices, the applications that we're building become much more kind of discrete functional parts, right? Each of which can be delivered in a container. Netflix, actually, one of our customers gives us really great, and I think it's on YouTube actually, but they did a session at Red Hat Summit a couple of years ago where they talk about essentially having to re-architect the entire Netflix application, where that was previously one application, right? So you go on to your Roku and you pull up Netflix. That was one huge application. And so what they did was essentially they ate the monolith. They broke down every single kind of part of that application into individual applications that they could then manage on a much smaller scale. If you're familiar with the 2 pizza rule, it's basically that with microservices, you really only want a team on a specific application that would be fed just fine by 2 pizzas, is essentially the gist of it. So how do we take these huge applications, break them into more functional parts so that we can then manage those individual parts as opposed to this giant application? And so, for instance, Netflix, when you log on, you get the da-da and you have to log in, that's one application. There's an application that feeds, your Watch Now list. There's another application that is doing calculations on what the top 10 things in your region are, right? And so there's that second line. There's another that filters just through the just added. And then there's all the kind of other filters that are happening based on your watching habits. There's another application that handles payment and et cetera, right? So they end up having from, probably 2 or 3 huge applications, breaking that into, thousands. And, the complexity of managing those applications, there's more objects, there's greater churn. There's a lot of new challenges that come with that. Configuration, service discovery. How do we let these applications know that they exist next to all these other applications, especially when they need to be able to kind of communicate with each other? How do we scale, especially based on traffic? How do we discover and actually fix failures when an application goes down? It's really, I would say, impossible to manage this manually. You know, clusters, OpenShift clusters, for instance, which we'll talk about in just a second, they commonly run, you know, maybe more than 1,000 containers, right? And updating those clusters is really infeasible without having some kind of policy-driven automated ways to do so. And so what Kubernetes does is it provides production grade or enterprise grade container orchestration. And what it does is automate container configuration. It simplifies scaling. You can actually essentially put in logic that says, you know, if this application is getting hit more than 100 times over an hour, I want you to scale this application maybe 10 times. Or maybe you can do it based on date, right? If you're, let's say, Amazon.com, you're scaling based on traffic, right? And you're probably scaling anticipating traffic, right? If you're in the States, Black Friday, now that starts, I think, like at the beginning of November. So probably, end of October, you're going to start to scale up a lot of the instances so that as traffic starts to spike, your end user is not really experiencing any kind of difference. Whereas on the back end, now you're running 3, 4, maybe 20 times as many versions of that application that they're hitting as you normally would. And so again, it's just a way of managing and simplifying at scale. Kubernetes can run anywhere, whether you want your infrastructure to be on site, you want it to be within the cloud, you want it to be some kind of hybrid. There's a lot that Kubernetes can do. And so, really in a nutshell, it's, really for more complex applications that have multiple components, it really vastly simplifies several things, one of which is updates. You're essentially placing each component in a container. It makes it really simple to make changes to those individual components without having to worry about any of the ripple effects. And this simplicity has led to containers becoming a really great way to develop and deploy microservices. And think of microservices as just an application with a single function. And it really benefits from containers because it provides those different applications with a clean separation between the components and the services. If you're not familiar, Kubernetes, open source container orchestration platform, it's really designed to help manage and distribute, help manage distributed and containerized applications at a massive scale. Essentially, you tell Kubernetes where you want your software to run, the platform just takes care of that. It puts it, in this cluster. This kind of enables things like edge computing and 5G and AI and ML. It also provides a unified API, so you can deploy, web apps or batch jobs or databases and applications that are in Kubernetes. They're packaged in those containers, right? They're cleanly decoupled from the environment so that you can, automate the configuration of the applications. You can maintain and track resource allocation, and you don't have to worry about where it's running. Now, we talk about container orchestration. What does that really mean? This is a container orchestration engine. And so there's really 3 primary functions. The first of which is schedulers and scheduling. Think of this kind of like a thermostat, right? So schedulers, they intelligently compare the needs of the container with the health of the cluster. And then they suggest where a container might fit within the cluster. So think of it like I said, like a thermometer, right? You tell Kubernetes, hey, I want my thermostat to be set to 70 degrees. And it's constantly checking on itself to make sure that it's resolving against the setting that you've put in place. And so there's self-healing. Obviously, there's job scheduling that you can put in place, but it's really, Kubernetes is meant to kind of seek to maintain the cluster health. And because, now developers don't really have to worry about, quote unquote, minding the temperature, they can just focus on building their apps, providing value to your business. The second piece, service discovery and load balancing. So, in any system, service discovery can be a challenge. Kubernetes doesn't solve this 100%. The more services that make up your application, the more difficult your application is to track and manage. Kubernetes automatically manages service discovery for you. We'll talk a little bit about some other pieces on top of that really assist with that. But let's say you wanted Kubernetes to run a service like a database. Kubernetes is going to essentially take notes about the service. We can query a list of information from that. And then it's also going to check the health of the services. So let's say Kubernetes detects that database has crashed. It's going to automatically attempt to restart it. And I can put in much more advanced checks like, let's say that the database has a crash, but it's just performing quite slowly. I can be alerted essentially automatically by Kubernetes, or even redirect the traffic to a backup if it's detecting that slowness. So that's where the load balancing comes into play. Essentially, these services are not scaling vertically, they're scaling horizontally, right? We're running duplicates of these services to make them more available. And the load balancer is a really key piece, and it distributes and coordinates the traffic across all these different duplicates. It makes it really easy to incorporate custom load balancing solutions like an HA proxy, or cloud provided load balancer like AWS has, or Azure, Google Cloud, or OpenStack, our private cloud offering. The third piece here, resource management. This is sort of going back to what we were talking about from the virtual machine side, but all computers have a limited amount of CPU, of memory. And let's say you have an application that's transcoding video, that's going to be really CPU intensive, whereas an application that's parsing text is going to be more memory focused. So this means we can essentially tell Kubernetes what resource limits or resource minimums we need. We can tell Kubernetes this application is going to be CPU intensive, so that we have proper resource management in place, right? It's all about intelligent scheduling. It goes back to that first point as well, right? We want to make sure that we're scheduling applications to appropriately use resources like CPU and memory, while also staying cautious about overutilization that can cause the entire cluster to become unstable and in fact impact all of those other applications running.
Hey, John.
Yeah.
Sorry to interrupt. There's a couple of questions. It seems like you're kind of talking about this right now, but the first one is, how different is OpenShift when compared to Kubernetes in terms of container orchestration and management?
Yeah, so I'm going to touch on that in just a second, but essentially Kubernetes is the engine within OpenShift. So think of, you go buy a car, Kubernetes is the engine, OpenShift is everything else that's around the engine, right? So, a lot of the, and this isn't to minimize OpenShift, I'll dive into this pretty in depth, but a lot of the bells and whistles, right? You can't drive just an engine. You need a lot of the other pieces that a car provides. And so we'll get into the specifics of that, but essentially, everything that you're doing with Kubernetes is still within OpenShift. It's really just a lot of added services. And Alex, I've got that slide that you love that kind of shows what that looks like in just a second coming up. The other question was?
There's one more. Yeah, it's how does OpenShift support migration of on-prem VMs and bare metal towards the public cloud container applications?
It's a good question. There's actually something built into OpenShift called OpenShift virtualization. So I always have kind of caveat with this presentation. I don't want to dog on virtual machines. There's still always going to be a benefit to applications running within VMs as opposed to on containers. And so actually built into OpenShift is a way to migrate virtual machines, and that could be from Red Hat virtualization, from VMware, one of the other providers as well, to run directly in OpenShift. And at that point, we don't really care where it's running, right? It may be in a public or private cloud. It may still be, on-prem, but the migration is something that can take place very easily within OpenShift. And then OpenShift, you can just say, hey, this is where I want that VM to run. But very good questions, and please keep them coming. And Alex, feel free to interrupt if there's a few more.
Yep, sounds good.
Cool. So, kind of wrapping up on the Kubernetes side, these four benefits are really what Kubernetes is offering: scalability, the ability to automatically scale your cluster based on your needs, right? Saves you resources, saves you money. I give the example all the time as far as like, the retail seasons, retail very seasonal. You got back to school, you got Black Friday. And so having the intelligence to automatically have not just the application scale, but the cluster itself scale, really, really key. Portability, mentioned this many times. Kubernetes can run anywhere. The applications that are running on top of Kubernetes, they can also run anywhere. Your experience is going to be the same, whether it's on site in your own data center, if it's on a public cloud, or a hybrid. And the same commands that you're going to use to engage with Kubernetes or OpenShift, which, full transparency, if you've used kubectl, OpenShift's command line structure, pretty much identical. Consistent deployments, I've touched on this a few times, right? But The containers, they embody the concept of immutable infrastructure. All the dependencies, a set of instructions that are required to run an application, they're bundled with a container. So they're running identically across no matter where Kubernetes is running. And then the separated and automated operations and development. It's really common for, at least in my experience, ops teams and devs to be in contention somewhat, right? Operations, they value stability. They're more conservative about change typically. And developers, they value innovation. They have a high change velocity. And Kubernetes kind of resolves that conflict. It allows operations teams to feel confident in the stability of Kubernetes and in the system, whereas containers save developers time. They allow them to have a much more rapid iteration cycle and really not have to worry about what kind of innovations they're making from an application perspective, because the way that it's going to run should be the same no matter what. A couple other slides around Kubernetes. I did want to touch on this. This is essentially what Kubernetes looks like under the hood. You really have a control plane and then some worker nodes within the control plane. Think of this kind of as a master node. It's really the brain of the cluster, and that's where the scheduling and service delivery and load balancing and resource management happens. As you scale, you're going to scale. You can scale both the control plane and these worker nodes. Within the control plane, you'll have your API server. That's the point of contact for any of the applications or the services. Any external or internal request goes to the API server. The server determines whether or not it's valid. etcd is also in there. Think of this like, if you're on the Linux side, right, this is where your memories are stored, right? If the control plane is the brain, etcd is where the memories are stored. And really, this is like a fault tolerant distributed key value store. It's really a critical component of Kubernetes. It acts as really the ultimate source of truth for the cluster and the configuration of the cluster. On the worker node side, that's where the actual applications are running. A worker node itself runs the application or runs the service, and there are a lot of worker nodes in a cluster. Adding new nodes is how you scale the cluster, and that's something Kubernetes can do on its own. Within the worker node, you have a kubelet, basically a tiny application that lives on that node. It's what communicates back to the control plane and then does requested actions from the worker node. So it's sort of like the arm. If the control plane is the brain, the kubelet within the actual nodes is the arm. And then you have the actual container runtime engine. So that's what actually is that OCI, Open Container Initiative, right? This is what's actually running the application itself. It's basically a conduit between the container itself and the underlying Linux kernel. There's a lot of stuff missing here, right? What's missing? So it offers the portability, the scalability, the automated policy-driven management, but it's not a complete solution. It doesn't have all the components that are needed to build and run and scale containers, right? It doesn't provide, let's say, an operating system. It doesn't provide the continuous integration, continuous delivery tooling. It doesn't have, storage, right? How about application services? There's a lot of work that has to go in to, let's say, setting roles and access control and multi-tenancy and secure default settings. Kubernetes does provide a lot of different pluggable, or it is a pluggable interface where you can plug in a lot of these different components and services. It offers you flexibility and choice for users, but it's a lot to manage, right? This is really just kind of the tip of the iceberg of all the different things that are not included as part of Kubernetes. And I think this is the slide I was referring to. This is actually an old screenshot. This is a map of all the different cloud native components that you would need to choose from in order to run containers in an enterprise production environment. So you can see here under orchestration and management, you've got Kubernetes. That's one piece. But you would need to, in order to really scale, plug in interfaces from a database perspective, from a subversion or a version control standpoint. How about CICD? How about API management? How about a place to store these images? That's really where a lot of the complexity comes into play. And so that's really what OpenShift kind of solves the problem of, right? Kubernetes on its own, you can install it, you can start playing around with it. It's not really very difficult, but establishing it as a platform for the enterprise to run, business critical applications takes a lot more. All of these different kind of pieces are things that you would need to add on to just the installation piece of Kubernetes, right? A good example is identity management. There's no identity management piece built into Kubernetes. So if you wanted to, you could go out to a vendor and get let's say Dex or LDAP or something and have them integrate for you. Or you could try to build something yourself internally. You'd need knowledge of something like LDAP or whatever your company is using. You would need knowledge of Dex, which is an open source identity system. You would need obviously a lot of knowledge on Kubernetes and integration systems to LDAP. You need to hook up Prometheus, which is a monitoring and alerting tool, or hook up some other monitoring system so you can get full visibility into the different operations and who's accessing. There's a lot of stuff, and that's just one piece, right? You essentially need to hire another person just to manage integrating identity management. And so that's really where OpenShift comes into play. And like I said before, OpenShift is really kind of the car where Kubernetes is the engine. Sorry, Alex, was there something?
Yeah, there was another question.
Yeah, go ahead.
They wanted you to touch on how OpenShift leverages CICD pipeline practices in a DevOps culture.
Yeah, so actually built into OpenShift is something called OpenShift Pipelines. It's out of the box support and it's based on Tecton, but we also provide out of the box support for Jenkins pipelines as well. Essentially, we want to make sure that, and I think this slide kind of demonstrates that, we want to give operations, but especially developers, a lot of these different tools out of the box, right? We want to provide them self-service infrastructure so that they can provision what they need on demand, as opposed to having to open up a ticket, get the infrastructure team to build that out, right? We want to have as much automation built in as possible. So that starts with having an out-of-the-box pipeline for CI/CD, but also having automated build and deployment, right? So that your developers, if they wanted to, they could build their own containerized applications themselves, whether from like source to image or from a Docker file, something like that. Or they can have the platform actually build the containers from source code or from the binary. And then that platform can then automatically deploy those applications across the infrastructure based on whatever characteristics developers have put in place and defined for the apps, whether it be how much resources should get allocated, where on the infrastructure they should be deployed, sometimes being considerate of like third-party licenses and need to be compliant with that. So making sure it's only running in a specific environment. Configuration management is a part of this as well. How do we automate that as much as possible to, so we can manage sensitive data? All that is built into the platform to ensure, a really consistent and environment agnostic application and configuration is provided to the application, no matter what the technology is actually being used to build the app or where the environment is. And then built into that really on the back end, right, because we need to talk about the entire development lifecycle, is how do we provide really rapid feedback to the developers on the actual application, right? And so that's built-in logging, built-in metrics, being able to have that integrated into OpenShift so that you as a developer can go in and inspect your application and get, all of the relevant logs and kind of visualized data on the immediate metrics that you need in order for you to study, how the application is behaving across different environments, which should be the same, but more so across changes that you're making to the application. And then be able to either roll back that application if necessary to an older version, or just make sure you're able to fix issues as early on as possible in that life cycle. So, I think this kind of demonstrates what I was trying to say as far as the car, right? This is really what OpenShift is. OpenShift is sort of enterprise Kubernetes, where you see here at the container infrastructure services side, really just the orchestration piece is Kubernetes. There is a storage component to Kubernetes, but it's not persistent. It's not really scalable, and it's not it's largely reliant on the OS's storage. So I wouldn't count that even as something that Kubernetes is providing. But how do we provide a lot of different things, not just to developers, but also security, your DevSecOps team, right? We need to have robust tooling for networking and all these different things. So this is sort of kind of the high level overview of what OpenShift is really providing, all of these different pieces. And Kubernetes is just the orchestration piece of that, which is obviously really key, right? It's the heart of OpenShift for sure. A couple other slides I know we're coming up towards the top of the hour. I want to make sure that we have enough time to go through everything. OpenShift 4, if you aren't aware, is our latest major version of OpenShift. We just released OpenShift 4.6 within the last, I want to say, month and a half. When we moved over to OpenShift 4, we made a lot of changes, especially on the way that it's deployed and managed. We've really streamlined the ability to deploy OpenShift from a managed perspective, right, a self-managed perspective, by really streamlining and automating a lot of the installation pieces, the day one operations, and even your ongoing day two operations. Building out ways to automate a lot of those things. One of those things that we would talk about is something called operators, essentially certified tooling provided by not just Red Hat, but let's say you wanted to add NetApp storage to your OpenShift cluster. Well, NetApp provides an operator that essentially kind of scripts, automates a lot of that deployment and provisioning and management. So having all of these kind of plugged in operators and having this plugged in automation really, really streamlines not just the deployment, but really the ongoing life cycle of OpenShift from a platform perspective. And it also enables, like I said, microservice development, cloud native applications, which will move more towards the edge, right? Or artificial intelligence, IoT, machine learning, all these kind of different functions. We need a modern application platform that will allow us to transform those traditional apps to start kind of experimenting with things like analytics and machine learning and serverless applications. Let's see, I've got a couple slides that I want to address before we jump into the training piece. Security, another really big part of this. I mentioned this at the very beginning, but from a platform perspective, a lot of the technology that you're looking at from a container perspective and even from an OpenShift perspective share a lot of the different technologies that Linux does. So if you have a dedicated Linux security team, they would be able to kind of swiftly move into securing the OpenShift platform. And obviously, if it's managed OpenShift, that's something that is largely kind of taken off the table, not really under your purview anymore. The other big thing that I wanted to mention is the self-service piece, right? And so this is actually what OpenShift looks like. You can see here, this is from the developer perspective. And we want to make sure that developers have the ability to interact with everything within OpenShift that they should have access to. So that includes operators or maybe specific operators that maybe help them to serve as a backend for their application, whatever it is. We want all this to be self-service. So we want developers to be able to create projects and deploy applications, but we only want them to be able to deploy to parts of the cluster that are dedicated for them, right? We probably don't want developers to be able to push things directly into production unless it goes through one of those OpenShift pipelines or something like that. But OpenShift provides a lot of those different capabilities from a role-based access control perspective, from a security constraints perspective, making sure that teams only have access to maybe an individual application when necessary, or to a specific part of the cluster when necessary, or maybe all of the above. And so a lot of room for kind of building standard policies or creating your own custom policies to really fine tune who has access to what. So with that, we're going to transition real quickly into kind of an overview of the training that we have available at Red Hat. This is really an overview of all of the different courses that we have from an OpenShift perspective. At the very top, you're going to see our DO 180 course. This is our really baseline foundational OpenShift course. It deals a lot with getting started with containers, understanding the relationship between containers and Kubernetes, and getting to actually work with containers that are deployed to Kubernetes, and then how that translates to actually working with OpenShift. It's really kind of a foundation for anyone on the administration or operations side, as well as on the development side, or even on the security side. It gives really a good jumping off point before going into, say, our administrator track, where you're going to go through everything from everything that you would need to do, actually configuring the cluster, providing access and managing projects and security and storage and networking. We have a course dedicated specifically to different ways to install OpenShift. If you don't do the full stack automated install, there is an opinionated install that you can really customize your deployment, but that becomes quite complex. And so we have a course that's really dedicated just to that. And then our third level OpenShift course on the administration side is really all about day two operations. It gets into how to scale, gets very deep into automation and operators and monitoring and metrics and all the different things that you'll need to do really to achieve platform excellence in a long-term stage. Vice versa on the developer track, our first level OpenShift development course, our OpenShift Development 2, is really focused on migrating applications, brownfield development, if you're familiar with that, as well as actually building and maintaining and consuming a CICD pipeline. From there, we really break into Agile Integration as well as microservices development. So if you're building microservices with something like, or if you're a Java developer, containers have been kind of a difficult proposition for Java developers. Java apps are just so gigantic and often take a lot of time for startup. Quarkus solves a lot of those problems, and so it's really enabling the ability for Java developers to come to the table from an OpenShift perspective. Service mesh is a way of actually providing service resiliency and discovery. It's a way of allowing and putting in place policies for these different applications or services to communicate with each other. That's something that's really kind of a standalone microservices focused course. And then we do have a Fuse Camel integration course that's built for developers, largely for Java developers who will be using Camel integration with their applications that they're going to be deploying into OpenShift. And then finally, the bottom left, we do have a security focused course that's really geared towards your DevSecOps team, who will be working with OpenShift or the containers therein from a security perspective. We do offer multiple ways to train, and Luke and the team at Global Knowledge will be able to walk you through kind of all the different modalities. We do offer, as of right now, virtual live instructor-led training. We haven't yet gone back to the classrooms yet, but knock on wood, hopefully we'll be sooner rather than later. As well as self-paced training. You can get access to one or more of these courses, as well as our learning subscription, which is essentially all of our courses in a bundle available to you to take self-paced, as well as with our new learning subscription tier, the premium tier, includes live instructor virtual led training as well. So something definitely to, if you're curious about any of these different modalities or any of the courses that I've mentioned before, I'm highly encourage you to reach out to Luke and the team at Global Knowledge to help you out with that. And then finally, we do offer certifications for most of these courses. As Luke said before, you'll get provided all of these slides so you can see, breakdown of the different courses, and the majority of those courses do have certification tied to that. So if certification is a priority for you, we definitely can accommodate that. And we do have remote certification available so you can actually take on your own hardware at home while some of the testing centers start to open back up. So I know that that was a lot of information and we were able to take some questions throughout, but we do have a few more minutes for questions. I did want to really quickly kick it back over to Luke to do a little bit of housekeeping before we go back to questions. So Luke, I'll kick it back to you, bud.
Awesome. Thank you, John. Once again, lots of really helpful information. And while you're thinking of any questions that you still have for John, just want to encourage you to check out the website. If you're wanting to get into one of those classes, reach out to us here at Global Knowledge and we can put you in contact and get you right into a session to learn even greater detail regarding OpenShift. So here are a few ways that you can get a hold of us if you're not currently already working with an account executive with Global Knowledge, but please go to globalknowledge.com and let us know how we can help you. Any final last minute questions that you have, put those in the Q&A. We've got about 2 minutes where we can take that. If we hear from somebody here in the next 30 seconds, great. Otherwise, just want to thank you for taking the time to be here today and to just be a part of this excellent session that Red Hat has provided via Global Knowledge. So with that, I'll be quiet for 30 seconds and see if anyone else has a last minute question. John, I think you may have cleared everything up. So job well done.
Try to, but
Yeah.
And again, appreciate you having us as always. And Luke and the team at GK will be able to really take care of you if you have any questions. If it's anything that's over Luke's head, which is not much, he'll bring me in. But again, thank everyone for your time today. And it looks like we did get one in the Q&A. I can't see it though, so maybe you or Alex can read it to me.
Okay, here it says OpenShift managed model is offered on what all public clouds?
Great question. So right now, Azure Red Hat OpenShift is a managed offering. So that's on the public cloud side, as well as just recently AWS offers something called ROSA, which is Red Hat OpenShift on AWS. So those are the two big ones. We also have Red Hat actually has a self-managed, or a managed version of OpenShift as well called OSD. That you may want to check out as well. But if you have existing relationships with AWS or with Microsoft via Azure, they're great solutions as well. I would mention that from a training perspective, really all of that kind of ops stuff really goes out the window, right? Because it'll be managed for you, but you'll still want to make sure that you're engaging for your developers, because there's still a lot of room for developers to be enabled within those environments as well.
Perfect. All right, all. That brings us to just about the top of the hour. So thanks again for joining. Thanks, Red Hat, for being here. And everyone, have a great rest of your day. Thank you.